Greetings once again, and welcome to my new calculus channel. My name is John Gabriel. So today, I'll try to answer a very good question from one of my subscribers. And let me just read it out to you. It would be great to know what you were thinking when studying from those books. For instance, it would be great to know what your first impressions and objections, stroke suspicions, were to concepts like change, instantaneous rates of change, limits such as this limit, and its algebraic manipulation. So let me tell you, I first remember coming into contact with the mainstream calculus when I was roughly 9 years old, and at that age I had already a reading IQ of a 23-year-old, a 23 or a 30-year-old even. So I was pretty advanced, and I spent a lot of time reading non-fiction books, and the encyclopedias used to fascinate me. I would start on one page and then sort of find something that I didn't understand and go to a completely different book in the set and read up on that, and then by the time a few hours had passed, I realized that I had to go back to the original place where I was reading to begin with. So one of the things that I saw is on page 600 in the Britannica, that edition of the Britannica, is something called the calculus of differences. Now, that's a misnomer because it's not a calculus of differences or a calculus of variations. It's just a calculus. Okay, so calculus of variations is something that moron Karin Uhlenbeck, who won the Abel Prize, claimed is different to calculus. It's no different at all, because what the calculus of variation supposedly deals with is optimization, contrary to Uhlenbeck's claim. Okay, so it's just calculus. It's not calculus of variations or calculus of anything. There is only one calculus. There is no other calculus, and that calculus has to do with the definitions of the derivative and the definite integral, and they're all related in one identity, as I proved in January 2020. So I kept an open mind until I learned about the mean value theorem identity, the one that you've seen in front of you here. So when I first looked at this, I was really puzzled. I asked myself, well, why on earth didn't they use that definition for the derivative? I did in the new calculus, and I realized a 100% rigorous new calculus, unlike the circular rot you find in mainstream theory. You don't see any limits in here, do you? Any infinitesimals or infinity? So, in any case, this identity comes from my historic geometric theorem, and I've explained it in previous videos, so you can just go back and read over that. Now, the graphic below is very revealing about how much calculus has changed since those very few entries. So, for example, you won't see today, let fx be a given function of the variable x. I mean, that to them would be politically incorrect, so to speak. The incorrigible apes will first say something like, let f be a function in r squared, right? In other words, real number squared. So that's just poppycock, because there is no such thing as a real number. There's no valid construction, neither Dedekind cuts or Cauchy sequences or Eudoxus reals. It's all nonsense. There is no such thing as a real number. The only numbers are the rational numbers. So in any case, this was the original definition, okay? And for starters, the mainstream morons obfuscated these definitions even further while claiming they had rigorized calculus. They had done no such thing. The use of omega was dropped for h. Next, they added the flawed concept of limit, not realizing that the expression called the finite difference is stated as an equation using my historic geometric identity. So in effect, what the buffoons did was to take the limit of a constant. Did it work? No, because they broke the rule. They called the limit of the constant 0. I'm sorry. Even in their own theory, the limit of a constant is a constant. It does not change. So, and if it is not 0, then the right-hand side, this right-hand side, is not equal to the left-hand side, and hence this identity is false. But we know that it's true because it comes from a theorem, and theorems are true. Do you get it? So the baboons reasoned as follows. They decided we'll take limits of both sides, but they just very, in their art of hand-waving, which they are all professionals at hand-waving, they decided they were going to treat this as a constant and this not as a constant. But you cannot treat them as anything but constants because they are both constants in my geometric identity. They cannot change, okay? So the first thing is that the limit of a constant is a constant itself, and they assume that f prime of x remains constant. In other words, they didn't bother taking a limit here because in that case, the limit of the left-hand side is equal to 0 because both these constants disappear. So the limit definition is itself circular because, as one MIT master graduate who had a debate with me said, he said this, he says, no, that is not the definition, blah, blah, blah. And he says, f prime of x is the number m, and then he uses, he uses it in the definition. This is the definition where I'm pointing right down here. Don't know about you, excuse me, but this is circular. So m is a derivative, which is used in the verification, a portmanteau of verification and definition. And in other words, it's all magic. So 1 second you see h here, and now you don't. You suddenly have the derivative. So until my historic geometric theorem, the apes of mainstream academia had no valid systematic way of computing the derivative, never mind the definite integral. In the graphic below, Kaesorg contradicts himself numerous times. He first says that one should understand that assuming a fact is, in order to be able to understand something, is the way it's done. And then he says, I absolutely cannot and did not assume that f prime of x is equal to 3x squared. So in another comment, he was called out about claiming that h can never be 0. And I believe it was, if I'm not mistaken, he says we never ever divide by 0. Okay. Well, I hate to tell you this, but that is precisely the equivalent thing that you do when you mess around with your little limit garbage. Okay, so the effect of taking the limit of a constant, mind you, taking the limit of a constant, mind you, the limit of this constant is equivalent to setting h equal to 0. It's the same thing. That's what equivalent means. By the time I was 13 years of age, I had taught myself the garbage of mainstream calculus. I knew it was a flawed formulation which needed fixing desperately. I later realized that it had to be completely ditched because it was so broken beyond repair that the formulation needed to take on a completely new approach using sound geometry. None of the nonsense such as set theory, ZFC axioms, infinity, infinitesimals, and all the other various flavors of bullshit in mainstream mathematics. So my first attempt to produce a credible definition of the derivative using the very same tools in mainstream was a huge improvement. You're looking at it right now. And you see, this here is actually equivalent to their definition with one extra positive thing, so to speak. The positive thing is that W over N cannot be 0 because N cannot be infinite. Okay, so and mainstream academics love to play around in their art of hand waving by claiming that they don't use infinity in one case and that in the other case they do, and basically they don't know what the F they're talking about. Okay, so one wonders if the previous form was purposely used in an act of willful deception. I bet, the way mainstream academics are so intellectually dishonest, nothing surprises me. The higher up the academic ape, in other words, with more credentials such as a PhD, the more the chances are that it is a well-known fact. This definition was flawed and they had no clue how to fix it. So, since they didn't know, the next best thing was to pile up tons of rubbish theory, such as the construction of real numbers, etc., etc., okay? So, it took me another decade to establish a meaningful link between finite differences, the derivative, and the definite integral. And you're looking at it, okay? So I actually produced a link. This uses the same tools and machinery of your bullshit mainstream calculus, Okay, you can actually test this if you know how to write computer programs. It works. So another 10 years, I was about 13 years old when I did this. Another 10 years passed before I dismissed all this garbage and started to develop the new calculus, okay, or to realize a new calculus. So at the beginning of the 20th century, there were some very bad ideas, such as instantaneous rates of change, etc., that were introduced by the idiots at top Ivy League unis. So one such idiot is Professor Gilbert Strang, if ever there was one. There is no such thing as a rate of change where a function is concerned because no change is taking place. As for the rate of change, there must be time involved. In other words, a time differential. And you can find all the details in this video link, okay? So in another video, I ridiculed the idiots at MIT Math Department. And I hate to say this, but all the mainstream academics I have encountered are incompetent, ignorant, arrogant, and incorrigibly stupid. And the few that know I am right are too cowardly to step forward and say so. And that, folks, is all I have for you. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.